All right, so what I have here, I have the connection points at the bottom, and I need to create a point that is between the rails that it's going to connect to. So it's going to go from this point to that point, and then it's going to connect down to this point, essentially. But I need to do it from midpoint to midpoint so that I can define a new triangulation position, right? The convergence points for the triangulation is a position along the vector, or I should say the line, that goes from this rail to the connection point. Okay, so let's do the rail. Let's find the midpoint, and then make the line, and then I'll show you the parameter. So we essentially have already subdivided this surface, and so I'm going to go back to try and find that reference again. And if you recall, these are our ruled surfaces. These are our surfaces that are reparametrized. And then likewise, these are our divided surfaces, our subdivided surfaces. Now, I could grab the edges from the deconstructed surfaces. However, the edges from the deconstructed surfaces have duplicate edges because they're quadrilaterals, so they have groups of 4, so there are 2 edges wherever they meet. I don't want that. What I want is the actual edges here. So I'm going to take this edge, that edge, that edge, that edge, that edge, so on and so forth to the end. So I'm going to use both of these. And 1, 2, 3, 4, 5. There are 5 of them. Yeah, that makes sense. Let me grab them. I'm going to grab them using another wireless just to kind of pull it down in reference. So I'm going to grab surface here. And remember, I'm going to use east and west. So I'm going to call this east web. I forget what terminology I was using for everything else, but I'll just call it east web subdivision. And this one is going to be the west. Or no, sorry, that one was west. My mistake. West web subdivision, and this is east web subdivision. And I will copy and paste those, make them wireless. And pull them down. Of course, turn them off too, up here. All right, so back to this. The fact that I have subdivisions here, it's a little... oh, you know what? I think I actually do want... No, you know what? I'm sorry. Let's go back to before we made this. Go back, back, back. Oh, great. You're going to go through all my typing. All right. There we go. So back to the beginning here. Rather than doing that, I think what I'd prefer to do is to do a surface subdivide. And so that's under surface utility, and it's this one, divide surface. So it's going to create a grid of points on the surface instead of the actual surface itself. Because if I pulled those down the way I was going to, I'd have to subdivide them again, and I'd still have the same problem. I just thought of that. So divide surface. If we divide the original surface, that would be this, and we divide it by this number of items. So the U will divide, the U we divide that much, and the V we divide this much. What it gives me is a list of points that are at the convergent points there, right? And there's only one point in every single instance. So as long as I can extrapolate which points are on either side, I should be able to draw one line between each one. So this one, yeah, so I am going to need a param, except it's going to be a point-based param instead. So this one is going to be the east rail points, west rail points, sorry, I'd keep doing that. And then you can copy and paste this down. And connect the other surface instead. Just double check that you did it correctly here by checking your surface, subdivide in your west rail points, east rail points. Rename this to east rail points. And if you care about making a wireless connection, do that. I do, so I'm going to. Alright, and then move them down. Alright, so now we're back in business. The key here is going to be to isolate the rail that goes across each one. And in order to do that, we need to look at what the groupings of these points are. So with a panel, my west rail points are paired up in groups of 2. So that kind of tells me that potentially I should maybe be able to just take my index item 0, my index item 1, and just make a line with each one. So let me just test that out. So I'm going to, let's see. I'm just going to kind of drop them down here, actually. I'll put them below. So I'm going to test that out real fast, my theory. So I'm going to do a list item, set list, list item. And I'm going to do, do I want to do it 0 and 2 in the same one? Yeah, I think I want to do 0 to 1. Yeah. So I don't want to do it as the same one. So I'm going to do an index item of 0 here, which gives me all the points on one rail. That's good. That's good news. I'll do another one. Whoops. Which gives me all the points on the other rail. So with this, I can create a line between the two and then subdivide it. So I'll go to curve line, and I'll connect those two. And then I'll subdivide that line by 2. I'm moving really fast, guys, so sorry if I'm losing you, but you'll have time to catch up. And then, of course, we have to go through and select the midpoint line. So that would be another list item, and it's going to be a list item index 1. So this list item here, index item 1, and that gets me my midpoint. So that's my midpoint for my west rail points, and you can just copy and paste the whole thing down for your east rail points. And replace those connections. There you go. These ones I'm going to group separately so I can kind of tell them apart. Alright, so I have my subdivided points down here, which come out in 2 separate groups. So that's kind of good, because if I was to, weave these two together into a group, then, or not weave actually, I'd have to just get them to be a set. But so basically, I just need to pair the two up, essentially. So if I have a point param, and I plug one list in, and then I plug another list in, it's going to be 2 and 2, huh? These are groups of 1. I need to flatten that, and flatten that. Sorry, no, that's not right. What do I want to do? I forget how to group that way. Just a sec. That's going to be that. That's going to be that. Hang on, just a moment. All right, so I'm going to kind of rush and do this a manual way. And I'm basically just going to take these two branches and explode them so that I can just kind of connect them the way that I really want to do it manually. So under tree, you can use explode tree. And this will allow you to get your group of 7 and your group of 7. So that's 7 and 7. And see how those are flattened lists? Those are your base point connections. And so these are groups of 7 as well. So that's 7 when it's flattened, and this is 7 when it's flattened. So I just want to make sure that I pair these up appropriately when I do my line. So if I'm going to go to curve and line, I just need to make sure that the input that I put here, so this is a, be careful what order you do too, but because these are your base points, you want those to be your B value. That means it's going to be the end of the line. So your param is going to start from 0. So this is going to be your base point param, and I'm just going to try the top one here to see if it's the correct line. Oh, great. So it's reading them in reverse order, so I need to reverse one of the lists. I don't recall. The reverse list here should be able to just switch them. There you go. Oh, wait, do we have a miscount? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 6 items. 7 items. Oh, right, because this is divide by segments, so I don't need the +1 up here. You guys should take the x + 1 off of your web subdivision count. There you go. Okay. So this gives us our line, and you're just going to have to do the same thing for the other case. So just copy and paste that down. You can plug your L in here, and then plug your top one in B over there. And it looks like in this case I don't need reverse, so I'm going to get rid of that and plug this in here. Okay. Questions on this so far? No questions. All right.